Hello guys, good morning to all of you. This is Maggi here, and now we are going to get discuss about the ZENER diode. So what is ZENER diode? So ZENER diode is a specific type of uh, diode which invented by the ZENER, and according to the inventor name, its name becomes ZENER diode. Okay, and it works in the breakdown region of the reverse biasing. So we can say that it is the avalanche voltage or reverse or breakdown voltage. Okay, so or zener voltage, and it works as a voltage regulator or voltage controller. Okay, so zener diode is a specific type of junction diode which invented by the ZENER, and according to its inventor name, its name become zener diode. Okay, it works in the breakdown region. So here the voltage whatever we produce, that is the avalanche voltage or breakdown voltage or zener voltage. Okay, as shown in this IV characteristic curve. Okay, and it works as a voltage regulator or voltage controller. Okay, so here P and N types of junction diode fabricated in such a way that they are highly doped in both region P and N. Due to this, its depletion layer becomes less than 10 raised power minus 6 meter. Okay, write down. In the zener diode, both P and N region highly doped. Due to this highly doping, its depletion layer decreases and become less than 10 raised power minus 6 meter. And here applied a very low voltage like approx 5 volt, then here produce a strong electric field like 5 upon 10 power minus 6, that means 5 into 10 power 6 volt per meter. It means we can say that the electric field produced in order of 10 raised power 6 volt per meter. Okay, and now whenever we draw the IV characteristic curve as shown here, this is IV characteristic curve, then such a condition when V becomes Vz, then form a drastic change in the current. Drastic change in current. It means, इसका मतलब ये हुआ कि अगर V की वैल्यू Vz हो जाती है, जेनर वोल्टेज के इक्वल हो जाती है, तो उस जगह करंट की वैल्यू में ड्रास्टिक चेंज आएगा, बहुत बड़ा परिवर्तन आएगा. सो सिंपली एज शोन इन द IV कैरेक्टरिस्टिक कर्व, व्हेन V इक्वल्स टू Vz, then formed a drastic change in the current, or simply we can say that here when the voltage become V equals to Vz, then without changing any potential, here formed a drastic increment of the current. Okay, so here due to this reason it used as a voltage control, because here we obtain a large change or drastic change in the current without changing any voltage, and that voltage is known as zener voltage. And now let me consider that how did this situation be created, then the current be increases. So here in it form how this current increases. Okay, so let me consider here then how did this situation be created, then where the current be increases. So here electron transmitted from P to N, and holes also transmitted from N to P. Okay, so due to this, reverse current be takes place in the increment, or reverse current increases due to the motion or transmission of electrons from P to N and holes from N to P. Due to this reason, a strong electric field produced 10 for 6 order, it means 5 into 10 power 6 volt per meter, which is suitable for the those those electrons which are available on the p region and accelerated from simply towards n region. So on the other words, we can say that whenever at the condition at V equals to Vz, when the electric field suitable for the withdrawing the electron from the host atom, that electric field is known as internal field emission or internal ionization field, and that's value is order of 10 raised power 6 meter per second. Okay, so simply we can say that this current be increases whenever electron transmitted from p to n and holes transmitted from n to p. So this reverse current be increases due to the movement of electrons from p to n and holes from n to p, and whenever this produce this strong electric field or this electric field becomes suitable at the V equals to Vz situation to the withdrawing of those electrons which are available in p region and accelerated from p to n, and simple we can say that those electrons which accelerated towards the n region. So that's a suitable electric field at V equals to Vz condition, which is suitable to withdrawing of the electron from the host atom, is known as internal field emission or internal ionization field. Its order is 10 raised power 6 volt per meter. And now let me discuss here then how did this work as a voltage controller. So this is the IV characteristic curve for the Zener voltage. This is the symbol of Zener diode, and here this is the uncontrolled voltage which converts into the control voltage. So you know that the voltage here some fluctuation in the if the some fluctuation formed in uncontrolled voltage, then output controlled voltage also be formed in some fluctuated value. Okay, so here applied a series resistor with RS with a series of Zener diode, and also attached this Zener with parallel with the load. So whenever voltage increases in here, then value of RS and IS be increases, and simply we can also say that the value of IL also be increases, but there is no any change in the Zener voltage. On the other side, if we decreases some voltage or some input voltage, then this current IS or this resistance decreases or IL decreases, but again here no any change in the Zener voltage. So simply we can say that in the increment or decrement of the uncontrolled voltage, increment and decrement formed in IS, RS and RL, but there is no any change in the Zener voltage. So in this way we can say that this voltage is used as the Zener voltage.